Good day, everyone. This is Gifted Brain, aka Saizu. Today we shall be considering indices 2, which is further examples on laws of indices. Under this study, we shall be considering 1. Application of the laws of indices, and 2. We will look at relevant exercises on this application of the laws of indices. So look at this now. Example 1. We want to apply all of these indices flat here now. You see, we have 8 raised to power 1 over 3 times 5 raised to power 2 over 3 all over 10 raised to power 2 over 3. How do we solve this now? This is quite an easy one. So, I have 8 raised to power 1 over 3 multiplied by 5 raised to power 2 over 3 all over 10 raised to power 2 over 3. And we can write this as, well, 8 raised to power 1 over 3 multiplied by 5 raised to power 2 over 3 all over, you see this 10 now, I can break it down further to 2 times 5 all raised to power 2 over 3. I'm doing this because I can see 5 raised to power 2 over 3 up, so I try to bring that out at the denominator. So this 8 written at the numerator can also be written as 2 raised to power 3. 2 raised to power 3 times 1 over 3, then times 5, because 8 is 2 raised to power 3 times 5 raised to power 2 over 3 all over 2 raised to power 2 over 3 times 5 raised to power 2 over 3. I'm just applying the laws of indices now. And this can also be, already, this can cancel out this because they are the same. So I'll be left with 2 raised to power 3 times 1 over 3 all over 2 raised to power 2 over 3. And this will give us, obviously, 3 here 1, 3 here 1 also. So that will give us 2 raised to power 1 over 2 raised to power 2 over 3. And so we can apply the divisibility law now. That will give us 2 raised to power 1 minus 2 over 3. And when you do this fraction, you have 2 raised to power 1 over 3. And so that's that about that. Let's look at another example, example 2 now. Okay, the example 2 says we should evaluate 8 raised to power 81 raised to power 3 over 4 minus 27 raised to power 1 over 3 times 2 raised to power 3. And so to solve this now, just we will simply say solution now. Solution. And so I have 81 raised to power 3 over 4 minus 27 raised to power 1 over 3 all over 3 multiplied by 2 raised to power 3. And this is quite an easy one. You see this 81 now can be written as, because of those multiple of numbers I know, can be written as 3 raised to power 4, then into bracket of 3 over 4 minus 27, which is 3 raised to power 3 multiplied by 1 over 3 all over 3 times 2 raised to power 3. And so this will give us 3 raised to power 4 multiplied by 3 over 4 minus 3 raised to power 3 multiplied by 1 over 3 over the denominator can expand. That is 3 times 8. And so this will give us, because this is minus, yes, I'm not going to say anything, we cancel out anything because of the minus. So I must deal with the minus first. So here, 4 here 1, 4 here 1. And that will give us 3 raised to power 3 now. Minus here, 3 here 1, 3 here 1 as well. That will give us 3 raised to power 1 over 24. And that will simply be 27 minus 3 over 24. And that will give us 24 over 24 equal to 1. Some people will be apt to say, this is 3 here. 3 should cancel out any 3. No, you cannot use 3 at the denominator to cancel 3 at the numerator in any way. The reason being that there's a minus. You must deal with the minus before you can say that. So obviously, if not, you do be wrong. So let's look at the third example now. So for this example 3, we have 343 raised to power 1 over 3 times 0.14 raised to power minus 1. And then we have 25 raised to power minus 1 over 2. So to do this now, simply, we're going to let's take 343 raised to power 1 over 3. You know, seeing 343, I know that is a multiple of something. That happens to be 7 raised to power 3 actually. So I'm going to write 7 raised to power 3 now. Then times 1 over 3. You see, because we know the multiple. That's the importance of the multiple of numbers we've learned. 0.14 times raised to power minus 1. That can be, first of all, the 0.14 can be converted to fraction, and that will be 14 over, that is outside the scope of this learning actually. I'm just applying, converting decimal to fraction, raised to power minus 1. So then times, the next one we have here would be 25 raised to power minus 1 over 2. And so that would be 25. That you can say 5 raised to power 2 times minus 1 over 2. This will give us 7 times 3 times, mind you, 1 over 3. Then multiply by this 14 over 100 raised to power minus 1 can be written as, will now be written as 100 now over 14. The minus will go away. That's the implication of the minus actually. It will invert it 1 over. Okay, let me change it to the normal way we always do a negative number. So that will be 1 over 14 over 100 raised to power minus 1, mind you. So times, this will be 5 raised to power 2 multiplied by minus 1 over 2. So eventually we are going to have, this will be 3 here 1, 3 here 1. That will give us 7 raised to power 1. That is 7 times, for this now, so there's no minus here again, it's just 1. Then we'll now have, because that's why we did 1 over. So the 100 will just simply come up. That will become 100 over 14. I don't want to put the power 1 because anything raised to power 1 is the same thing. So the power 1 is as good as gone. Then times again. Here we have 2 here 1, 2 here 1. We have 5 raised to power minus 1. And so this will give us already 7 can go here 1, 7 can go here 2. Then we have 100 now over 2 times 1 over 5. Because 5 raised to power minus 1 can be 1 over 5. So 5 here as well 1, 5 here, that will give us 20. So we have 20 over 2, and that happens to give us 10. So that's that about that. So let's look at example 4. So let's solve this now. We have 4 into bracket 2 raised to the power n plus 1 minus 2 raised to the power n plus 2 all over 2 raised to the power n plus 1 minus 2 raised to the power n. But this is very, very simple. First of all, I want to start by saying, you see, if we have 2 raised to the power n multiplied by 2 raised to the power 1, it simply can be written as, using the first law of indices, 2 raised to the power n plus 1. So it means that if I say 2 raised to the power n plus 1, I can write as 2 raised to the power n times 2 raised to the power 1. Again, mind you that if I have 2 raised to the power n times 2 raised to the power 2, it can also be written as 2 raised to the power n plus 2. So it means that anywhere I see 2 raised to the power n plus 2, I write as 2 raised to the power n times 2 raised to the power 2. So we are done if we know this. So this, the number can be written as, the numerator can be written as 4 into bracket 2 raised to the power n multiplied by 2 minus, or I say 2 raised to the power 1, but that is 2 actually, minus 2 raised to the power n multiplied by 2 raised to the power 2 all over 2 raised to the power n times 2 raised to the power 1 minus just 2 raised to the power n. This will have as 4 multiplied by 2 raised to the power n. 2 raised to the power 1 is just 2, so no problem. Minus 2 raised to the power n multiplied by 4 all over 2 raised to power n multiplied by 2 in brackets, and then 2 raised to power n. Now, this can be written as, I will use the 2 inside this bracket, this 2 now, multiply the 4, that will be 8. Then into 2 raised to power n, minus, here we have 4 into 2 raised to power n. Now, all over, here we have 2 raised to power 2 times 2 raised to power n. So, minus, so there's a minus here, 2 raised to power n. Now we can factorize, understand. 2 raised to power n is common, so 2 raised to power n, then in brackets, if I factorize 2 raised to power n, firstly, we have 8 minus, factorize 2 raised to power n here, or removing 2 raised to power n here, we have what left here is 4. So, all over. For the second one, factorizing 2 raised to power n, I would have 2 for the first one. If I factorize 2 raised to power n here, we have for the second one, 1. So, we are as good as almost being done. So, this is 2 raised to power n. 2 raised to power n can cancel 2 raised to power n first of all. So, we have 8 minus 4, and that happens to be 4 over 2 minus 1, which happens to be 1. So, my answer is simply 4. So, that's that about that. So, let's look at this now. Third root of 64 raised to power minus 6 raised to power 1 over 2. This can simply be written as, because we are saying third root now, solution. But we are saying third root. So, that can be written as, first of all, whatever is in inside the square root, we have that third root still existing. So, but 64 can be written as 2 raised to power 6, and then r raised to power minus 6, then raised to power 1 over 2. So, that will simply be our third root still existing. Third root still existing, we will now have 2 raised to power 6 times 1 over 2, then times r raised to power 6 times again 1 over 2. So this will give us simply 2 raised to power 3 r raised to power, this is minus 6 please, so r raised to power minus 3. Before I now say my third root. So my third root now means third root of 3. This can be third root of 2 raised to power 3 times third root, if you want to do it this way, of r raised to power minus 3. Quite an easy one actually. Third root simply, if I have third root of a now, is simply a raised to power 1 over 3. So this can be written as 2 raised to power 3 now, multiplied by 1 over 3, then times 3 r raised to power minus 3 now, multiplied by 1 over 3. So now this will give us 2 multiplied by, because 3 here 1, 3 here 1, that will give us just 2 raised to power 1, which is 2. Then here 2, minus 3 here 1, 3 here 1, that will give us r raised to power minus 1, and that is 2 times 1 over r. So my answer is simply 2 over r. So that's that about that. Let's look at the last example before we take exercises. Let's look at this last example. We have 4 raised to power minus 2 over 3. Minus 2 over 3. Okay? So, since I know that 4 is 2 raised to power 2, I can write it as 2 raised to power. Sorry, there's a large mistake there now, so I'll be correcting it. Minus 3 over 2, please. So, since I know that 4 is 2 raised to power 2, I can write as 2 raised to power 2, then multiply by minus 3. You might expect me to take the last rule of indices I gave, right, which is taking the square root of 4. But I may not need to do that as well. Whichever way that that is simpler for you, you can take that approach. So minus 3 over 2, 2 here 1, 2 here 1, and then this will be 2 raised to power minus 3, and that will be 1 over 2 raised to power 3. So you can leave your answer like this, or you can write it as 1 over 8. Does not matter. Okay, look at the B now. The B is 343. 343 raised to power 2 over 3. And this is quite an easy one. Everything looks easy for me, don't mind. But actually, it's quite an easy one. You see, this can be written as 7 now. 7 raised to power 3. Because 3 for 3 is 7 raised to power 3. Then times 2 over 3. And this will be 7 raised to power 3 times 2 over 3. And obviously, 3 here 1, 3 here 1. That will give us 7 raised to power 2. And then we have 49. And then lastly, for the C, 0.001 raised to power 3. Quite an interesting one. Convert to fraction first. That is 1 over 1000. Then raised to power 3. So you must learn to convert decimal to fractions. So this can be written as 1 over 10. 1000 is 10 raised to power 3. So you can take that and then put your 3 here. So this will simply be 1 raised to power 3 over 10 raised to power 3, then times 3 again, raised to power 3 again. So that would be 1 over 10 raised to power 9. You can stop here. So that's that about that. So we can take the following exercises and evaluate on our own. So you can try the following exercises now. There are 3 exercises here, 1, 2, and 3. So this is the 2 and 3. That's that about, and that's all about indices. We're looking at what we want to look at now. Actually, is exponential equation. That's the next thing we'll be looking at, exponential equations.